Close your eyes if you like, and picture a shoreline at night. The air is cool and clean. The sea breathes in long, slow tides. Each wave rises, stretches, and dissolves, leaving behind a glassy hush. Above, the sky is a velvet lantern, its tiny embers drifting farther than the mind can follow. You can almost hear the quiet hum of distance, the soft whisper of what is older than memory. Now let your attention soften, as if you're listening for a sound you've never heard before. Something gentle, something infinitely patient. We call it the Big Bang, the bright beginning of time and space. Yet even the name feels like fireworks, too loud for something so tender and foundational. It wasn't an explosion into empty space, not a detonation in a dark room. It was the unfolding of space itself, everywhere at once, a baby blue fabric knitting itself from nothing we can touch. From that hot, dense bloom came stars and dust, oceans and hands, music and questions, especially this one. What existed before the Big Bang? The question curls around the tongue like a riddle from the sea. Before, we say it easily, because in daily life, before and after is the way our stories move. Breakfast comes before lunch, winter before spring, inhalation before exhalation. But when we aim this simple word at the beginning of everything, it becomes slippery, like trying to walk north of the North Pole. Is there a before, when time itself might be the very thing that began? In the quiet of a bedroom, between the rhythm of your breath and the dim glow from a streetlight, a truth sometimes steps forward more kindly than any textbook. There are many ways to answer the question, and each one is a doorway. Some say there was no before, because time starts at the Big Bang. Some say the universe cycles endlessly, expanding and cooling, then folding and beginning again, a heartbeat too vast to measure. Others imagine a sea of universes, where ours is just one bubble in a frothy, eternal bath. And still others whisper that the universe came from nothing, a strange word in physics, not emptiness, but a kind of fertile silence, a quantum stage where possibilities murmur to themselves in the dark. The good news is that you don't have to pick a doorway yet. Tonight, you can just walk the hallway, slowly, touching the cool walls of each idea, feeling their textures. We will move gently, because this is tender ground, our origin, our inheritance, our question under the question. What does it mean to have a beginning? What does it mean that you, right now, are held in time that had a first page? Let's begin with what we know. The universe expands. Across the vastness, galaxies drift apart like lanterns on a lake, their light sliding through the stretched fabric of space, turning from blue to red as the lake widens. When astronomers trace this motion backward, the lanterns draw closer, the lake shrinks, the light shifts back, and everything becomes hotter, denser, more luminous. Follow that road far enough, and you arrive at a time when the universe glowed like the surface of a furnace, too hot for atoms, then too hot for even the scaffolding of subatomic particles. The equations of general relativity, our great poem of gravity, whisper that, if we extend the line, the density grows without bound. A singularity, they call it. A point where the equations can't proceed, a horizon where our map says simply, here be dragons. But maps can end, not because the world does, but because we need a better way to draw it. And that's what the beginning is for us. The place where gravity and the quantum Einstein's smooth fabric and the jittering rules of the tiny begin to talk over each other. A stage is set for both, but neither script alone can carry the first scene. So, what existed before? Perhaps the first answer is gentle and simple. The question may be like asking what lies north of the North Pole. If time is part of the universe, then before time is not in the universe. It isn't a place to stand or a moment to remember. If the timeline itself is a circle that closes at the beginning, then stepping beyond it may be like stepping off the edge of a painting into the air. Maybe there was no before, because the word itself depends on a clock that didn't yet tick. Yet, listen again. The sea keeps breathing. The universe is large enough for many possibilities, and our curiosity has built bridges farther than modesty would think to try. There are models, beautiful, careful ideas that sketch what the prelude might be, or how the beginning might be softer than a hard wall. Some show a universe that bounced, contracting before expanding. Some show a past where time is just another direction, curved smoothly to a boundary that is not a wall but a rounding off, like the Earth at its southern tip. Some show a mirror world on the far side of the Big Bang, time flowing the other way, a twin universe where what we call after becomes someone else's before. Can we test any of this? Can we listen closely enough to the sky to hear the lingering harmonies of a time before time? In the fossil light of the cosmic microwave background, in the way gravitational ripples twist that light, in the arrangement of galaxies like dew beads on a spider's web, there might be fingerprints, probing, quiet, almost lost to noise, but there. Sitting with that possibility, we feel smaller, but also held. Ignorance is not emptiness. It is spaciousness. It is the night sky before dawn. For now, we'll take another breath and stay with the question. What existed before the Big Bang? In a moment, let's walk closer to the edge, to the place where equations tremble and metaphors reach out their hands, and let's listen to what early science has already said and what it could not yet say. Imagine a snow globe sitting on a wooden knit stand. Shake it gently, and flakes swirl through a tiny city. Watch for a while, and the flakes fall, then rest. If you could run the film backward, you'd see the flakes lift from the streets and return to the glass like thoughts gathering themselves. For a long time, cosmology has done something similar with the universe. Rewind the picture and see everything draw closer. But unlike the snow globe, the universe isn't moving through pre-existing space. The globe itself is growing. The glitter isn't traveling through the room. The room itself is opening. This idea space expanding comes from the mathematics of general relativity and the observation of distant galaxies. In the late 1920s, Edwin Hubble measured how galaxies' light is stretched, redder than it should be, and found that this stretching increases with distance. The simplest explanation is that space itself is expanding, like dots drawn on a balloon's surface moving apart as the balloon inflates. This leads to a cosmic narrative. Once, the balloon was smaller, hotter, more uniform. As it expanded, it cooled, allowing particles to settle into atoms. Around 380,000 years after the beginning, the universe became transparent, and light set free then now reaches us as a faint, chilly glow. The cosmic microwave background whispering the conditions of a young cosmos in a nearly perfect, childlike script. The script has smudges, and in those smudges are clues. Why is the cosmic microwave background so uniform in temperature across regions of the sky that, by simple reckoning, could never have touched? Why do we see so little curvature in space, as if the balloon is unimaginably large and gently rounded? To iron out these mysteries, cosmologists proposed inflation, a brief, furious growth spurt in the earliest instant, when the universe multiplied its size unimaginably fast, smoothing wrinkles and stretching curvature so thin it looks flat to our eyes. Inflation also helps explain why tiny quantum jitters could be inflated into the seeds of galaxies, the baby fingerprints that would later grow into star cities and clusters. But rewind farther than inflation, and the lights dim. In the first fractions of a second, even before the cosmos was a second old, we run into a wall, the Planck time, around 10 to 43 seconds after the Big Bang. Earlier than this, the physics we know, relativity for the large, quantum theory for the small, refuse to play nicely together. The singularity appears when we use only Einstein's equations, a sign that we've pushed them beyond their range. We need a quantum theory of gravity, a way to let space and time themselves have a kind of graininess, the way water, smooth at a distance, reveals molecules when you dip your finger into it. Until we have a full theory, scientists use careful, imaginative proposals to describe the beginning. One is known as the no-boundary proposal, associated with James Hartle and Stephen Hawking. It suggests that the universe, in its earliest breath, had no edge in time, the way the Earth has no edge at the South Pole. If you walk to the South Pole and ask, "What is south of south?" the answer is not a place. The direction dissolves. In a similar way, near the beginning, time may have curved smoothly into a kind of space-like direction. The universe would not start with a bang, but with a rounded-off beginning, like a sphere, with no boundary that demands a before. In this picture, asking what preceded the Big Bang is like asking what the color blue smells like. The categories don't meet. Another proposal from Alexander Vilenkin and others imagines the universe tunneling into being from a kind of quantum nothing, a state with no classical space and time, but not the philosophical void. In quantum physics, particles can appear and vanish in allowable ways, borrowed briefly from the uncertainty that saturates the smallest scales. Extend that logic carefully, and a universe can emerge, not from emptiness in the everyday sense, but from a realm where existence is a softer word, and the line between something and nothing is a blurred shoreline in fog. It's a daring idea that being itself can begin as a kind of fluctuation, with the universe as the allowed path that blossoms from a placeless, timeless seed. If these are beginnings without a before, there are also ideas that make room for a prelude. Imagine a cosmic spring. Press it, and it stores energy. Release it, and it bounces. Some models of the universe describe a bounce instead of a bang, a previous contraction smoothing and setting the stage, then rebounding into expansion. In these views, time stretches past the canonical beginning, and before the Big Bang means a different chapter of the same book, written in a script we don't yet fully read. There are cyclic tailies too, where the universe rhythmically expands and resets, not in exact repetition, but in a grand, calming pulse cooling, diluting, then rejuvenating under new conditions. These possibilities are not fantasies. They're disciplined speculations, guided by equations and by a devotion to the sky's evidence. If they sound like lullabies, it is because the truth in physics is often gentler than we expect. The beginning may not be a cliff. It may be a shoreline where waves turn back. But how do we choose among them? The universe is not a guessing game. It is a field of careful listening. The plan is to search for whispers in the cosmic microwave background, for patterns that inflation might leave, for symmetry that a mirror universe would demand, for scars that a bounce might imprint subtle curves in the way light is polarized, faint non-randomness in temperature speckles, delicate variations in the distribution of galaxies. Our instruments are like nocturnal creatures, eyes widened, ears attuned, learning to hear the hush. And the hush contains another puzzle, a warm candle flicker underneath the question of Ming. Before, the universe today has an arrow, a direction in which processes naturally go. Eggs break, coffee cools, memories form behind us, not ahead. That arrow is tied to entropy, the measure of how many ways things can be arranged without changing the big picture. A low entropy beginning, a very special state, provides the arrow we live inside. Why was it so special? Why did the universe begin in such an improbably tidy condition? This is the past hypothesis, the assumption that the early universe had unusually low entropy. If we can understand that, we might understand why time itself seems to flow, and perhaps whether before can be sensibly defined. We're getting close to the heart of the matter. In a moment, we'll step inside the workshop of deeper theories and bolder experiments, bounces and cycles, mirror times and eternal inflations, and listen for the sound these ideas make when they meet the data and when they curl around the arrow of time. Picture a pendulum in a quiet room. Pull it to one side, let go, and it arcs gently across, back and forth, each swing a poem about balance. Now imagine that pendulum is the universe, and the arc is not left to right, but contraction to expansion. A family of models bouncing cosmologies tries to make cosmic sense of this motion. In some of them, quantum gravity provides a cushion. As the universe shrinks and density rises, the fabric of space resists collapse, and instead of a singularity, the universe rebounds. Loop quantum cosmology, a branch of loop quantum gravity, suggests that space isn't continuous like syrup, but woven from tiny loops, a granular digital texture. At extreme densities, this weave creates pressure that halts the rush and triggers the bounce. Time flows smoothly through the turnaround. Before the Big Bang is just before the bounce. Other versions come from string theory's landscape, where the ingredients of matter and forces vibrate like notes on microscopic strings. An ekpyrotic model imagines our universe as a three-dimensional brain floating in a higher dimensional space. In that higher space, brains can drift, collide, and separate. The collision is our Big Bang, a release of energy into our brain, heating and igniting what becomes our familiar cosmos. Before the collision, the brains moved, pulling the ideas of before into a pre-Big Bang storyboard. And there are cyclic forms of this, where collisions happen again and again across eons, giving us a cosmic heartbeat that leaves each new cycle smoother and flatter, reborn without a singularity. There is also the idea of conformal cyclic cosmology, proposed by Roger Penrose, which is as soft and strange as a foggy morning. In this picture, the remote future of our universe far beyond trillions of years, when black holes have evaporated and matter is thin and cold, can be rescued so that time stretches, and the details we care about, our rulers and clocks, lose meaning. At that extreme, the universe becomes conformally simple, much like the early universe was. Penrose suggests that the end of one cosmic eon can be smoothly joined to the beginning of the next when this rescaling is applied, making the Big Bang not a start, but a handoff between ages. In such a world, the question what existed before becomes whose end fed our beginning. He's even looked for possible fingerprints, subtle circles in the microwave sky where the passing of long-vanished black holes in a previous eon might leave a delicate winged pattern today. The evidence remains debated, but the question remains deliciously open. Now imagine a mirror held up to time. In CPT symmetric model CPT, standing for charge, parity, and time reversal symmetry, our universe may be paired with a twin that is a mirror not in space, but in time. On the far side of the Big Bang, according to this idea, there could be a universe where time flows in the opposite direction from our perspective, where matter there would look like antimatter to us, and the arrow of time points away from the Big Bang in both directions. The bang becomes not the edge, but the shared point from which two temporal rivers flow outward. This can help explain why the universe began in a low entropy state without special pleading. The Big Bang is a central, simple point, and complexity grows as you move away in both temporal directions. If true, before exists, but it is not before in our sense. It is a place where someone else's memories would form opposite ours. And then there is eternal inflation, which suggests that our Big Bang was a local event, a bubble where inflation ended, while elsewhere inflation continues, spawning a multiverse. Countless bubble universes nucleating like stars, forming in a vast fog. Each bubble can have its own laws, its own constants, its own narrative. In this view, the before of our Big Bang is a larger inflating space where pocket universes bloom, or perhaps even another bubble crashing into ours, seeding imprints in the sky. The trouble and the wonder is that such a multiverse may be forever difficult to test directly. Yet it makes sense of some otherwise puzzling facts, like why the parameters of our universe seem so gently tuned for complexity. Perhaps we live in a bubble where those parameters happen to allow stars and chemistry, because in the set of all bubbles, observers appear in those that do. These models face deep questions. A theorem by Arvind Borde, Alan Guth, and Alexander Vilenkin suggests that any universe that has been, on average, expanding must be past incomplete under certain conditions. It can't be eternal in the past in the simplest way. Eternal inflation, for instance, might require a beginning of some kind. Bounces try to navigate around such boundaries by changing what counts as expansion on average, or by altering the physics near the turnaround. The details are technical, but the story is poetic. Our equations test the borders of story itself, asking whether time has a first syllable or is a line that bends back, a cadence without a final downbeat. And what of black holes? They are the universe's deep wells, where gravity wraps around itself and light knots. Some thinkers have explored whether new universes might bud from black holes inside. Beyond the event horizon, space could pinch and then re-expand, creating a baby universe disconnected from its parent. If so, a kind of cosmic natural selection might occur, favoring universes that make many black holes. It is speculative, but it hints at a family tree of realities, where before becomes upstream and ancestry is measured in collapsed stars rather than DNA. With so many possibilities, how do we listen for truth? The sky is a library. The cosmic microwave background is a page that remembers. Its tiny temperature variations hold the record of quantum tremors magnified by inflation or the callings of a contracting phase. Polarization patterns swirls called B-modes could be signatures of primordial gravitational waves, which inflation might produce in a characteristic way. If a bounce occurred, it might silence some of those waves or seed other distinctive features. Future measurements with more sensitive satellites and ground-based telescopes will press their ears closer to that ancient light. Meanwhile, surveys of galaxies map the cosmic web, a lace of filaments and voids, reflecting the initial conditions with a very slow echo. Subtle, non-Gaussian eddies, the way fluctuations deviate from a perfect simple randomness, could point to specific physics in the first moments. And there is a new frontier at very low radio frequencies, mapping the dawn of the first stars through 21-centimeter hydrogen signals. Even this late dawn carries a faint memory of what came before. All of this circles back to the arrow of time. If the Big Bang is not a hard beginning, if there was a before, why is the direction of time so clear to us? Why is the past neatly ordered and the future fuzzier? In cyclic models, each refresh might reset the entropy in clever ways. In mirror time models, entropy climbs away from the central point in both directions, making our arrow local but natural. In bounce models, the contraction phase may have had its own arrow, its own history of stars and stories, or it might have been so smoothing and quieting that the bounce naturally delivered a low entropy state. We do not yet know which of these lullabies the universe is humming, but we can feel the music's shape. It is patient, symmetrical in places, gently broken in others. It cares about simplicity, about boundary conditions, about how a story begins without being arbitrary. And like all good music, it breathes. In a moment, let's widen the view further, not just to other cosmic timelines, but to deeper layers of reality itself. What nothing means in physics, how time might emerge from entanglement, and how space-time could be a quilt sewn from information. Perhaps before is not earlier, but deeper. A quiet room, a cup of tea warm in your hand, steam rising in invisible curlicues until it cools into the air. Time feels like the distance between sips. But what if time is not a fundamental thread, but a pattern that emerges, like the image in a woven tapestry that only appears when enough threads are pulled together? In quantum theory, systems can become entangled, correlations so intimate that describing one without the other is like describing a melody without rhythm. Some researchers have suggested that time itself might arise from such correlations. In the Page-Wouters picture, for instance, the universe as a whole could be in a timeless quantum state, while subsystems like you and your teacup experience the passage of time through entanglement with a clock subsystem. From the view of the whole, there is no ticking. From the view inside, the ticks are as real as heartbeat. If something like this is true, then before the Big Bang might be the wrong question. Instead, we might ask, when did the conditions that allow a notion of time to emerge first appear? There is also the thermal time hypothesis, a more mathematical story in which time's flow is associated with the state of a system rather than an external parameter. Here, the arrow of time and the pace of time are not imposed, but arise from the distribution of energy and information. It's as if the universe's mood, its temperature and arrangement, decides how time should move, like wind deciding which way a river's ripples will lean. Now think of the quantum vacuum, not a void, but a restless field where particles, or rather their possibilities, flicker in and out of description, not as little spheres popping into existence, but as vibrations allowed by uncertainty. Fields pervade space. Even empty space has structure, energy, and fluctuations. When physicists say the universe might have sprung from nothing, they often mean from a state without classical space and time, but with quantum rules. A nothing that is less like a blank page and more like a library with the lights off. Open the lights, and the words appear. In this sense, before the Big Bang could be a region where our words space, time, particle haven't been taught their meanings yet. There is yet another deep idea, born in the borderlands of gravity and quantum mechanics: holography. In certain theories, particularly those shaped by string theory, the physics inside a region of space can be fully encoded on its boundary, like a three-dimensional world whose essence is written in 2 dimensions. If space-time itself is holographic emerging from patterns of quantum entanglement, then asking about before might be like asking what existed before the weave became tight enough to look like fabric. The deeper layer is not earlier. It is more fundamental, like a loom beneath the cloth. Causal set theory offers a different metaphor, that space-time is not smooth and continuous, but a growing collection of discrete events, like raindrops leaving a pattern on the pavement. Time is the order of those drops, the partial ordering that says which causes which. The Big Bang would then be the first sprinkles in a storm, not a singular arrival, but the start of a process that accumulates. Before might be a region of negligible density of events, or nothing at all in the causal sense, because cause itself grows with the set. We meet again the question of entropy, and with it, memory. Why do we remember yesterday, but not tomorrow? One answer is that the past contains records: the cooled tea, the footprints in snow, the photons bouncing off a page, while the future does not yet. Memory is a physical process, one that increases entropy as it writes. The universe's low-entropy youth provided a fertile ground for records to grow, for stars to cook heavy elements, for planets to form, for brains to make pictures of their own lives. If the Big Bang is one end of the road where entropy was low, then the arrow points away from it on both sides in some models, or at least it points outward in ours. Understanding before becomes entangled with understanding why the universe had those pristine first conditions. It's tempting to look for purpose here, to turn the cosmos into a myth with goals. Science steps carefully. It asks for models that produce testable hints, specific spectral patterns, polarization swirls, distributions of galaxies, ratios of elements, little numerical fingerprints that say, yes, this story leaves this mark. The coming years will carry new instruments to the dark, more sensitive measurements of the microwave background's polarization, surveys that chart millions of galaxies with exquisite detail, radio observatories that listen to the hydrogen fog of early times, and gravitational wave antennas striving to hear the faint tremor of space from the first instant. Each of these is a stethoscope pressed to the universe's chest, listening for the rhythm behind the breath. But even as the measurements sharpen, they all remain soft around the edges. It is okay that we do not know. We can hold multiple ideas in our hands like sea glass, turning them to catch the light. Bounce, no boundary, mirror time, eternal inflation, brain collisions, baby universes, entanglement-born time. Each glows in a slightly different way. Each is an attempt to soften a singularity into a story. The best of them are humble. They admit their uncertainties. They offer ways to be wrong. They ask us to look up with quiet attention and ask the sky to weigh in. And as we do, the human meaning gathers. If time emerged, if our idea of before dissolves near the beginning, then our lives are not perched on the edge of a void. We are in the middle of a process, a long, slow unfolding where meaning is woven from relationships, from memory, from the warmth of tea in chilly hands. If there was something before, perhaps a prior universe contracting, or a mirror world where time runs opposite, then we are part of a larger quilt, a patch sewn to others we may never see. Either way, the lesson is tenderness. The universe permits beginnings. It permits order to arise, tears to fall and dry, atoms to arrange themselves into listening, into love. Stand outside under a clear sky. Feel the ground. The starlight you receive left its sources long ago, walking across expanding space, stretched into lower notes by the universe's breath. In each photon is a tiny record, a postcard from a distant past. Our models of before aim to find an even older postcard, written not in light, but in the pattern of patterns, the way the whole picture was arranged at its first blush. The hunt for that postcard is slow, and it may surprise us with its handwriting. In a moment, we'll gather the threads and return to the question, letting all these possibilities settle like snowflakes in a glass globe. We'll close not with an answer carved in stone, but with a way to live with the mystery, so that the unknown becomes a friend, a quiet companion that makes the night feel vast but kind. Breathe in. Let the air fill you like a tide, lifting a small boat. Breathe out. The room settles back into itself. The question rests on the pillow. What existed before the Big Bang? By now, you've walked through a calm museum of answers. One gallery held the idea that before may simply not apply, that the Big Bang is like the Earth's South Pole, a smooth rounding where the direction we call earlier dissolves. Another displayed a bounce, a cosmic pendulum that swings from contraction to expansion without breaking. A side hall showed a mirror universe, time flowing away from the Big Bang in both directions, like two rivers parting from a single spring. There were rooms of eternal inflation, a multiverse of bubbles budding in a wider inflating space, and rooms where eons hand off to eons like runners passing a torch. Across the museum, quiet placards spoke of entropy and arrows, of no boundary beginnings and quantum tunnels, of time emerging from entanglement and space-time blossoming from information. If the mind feels full, let it be full like a night sky, not like a crowded shelf. You don't need to keep every name. What matters is a shape of understanding, a feeling for how careful minds have tried to cradle the beginning without squeezing it. You are allowed to prefer one image, to let another whisper in the background. Science, too, prefers gently, guided by evidence. It holds its favorites loosely, ready to let them go when the sky asks for a different song. So, what existed before the Big Bang? The most honest answer we have, softened by humility but sharpened by decades of learning. Is this? The word before could be a misstep if time itself unfurled with the universe. In that case, there was no before, not because there was nothing, but because earlier isn't a direction you can walk. Yet it could also be that our Big Bang was a passage, a transformation from a prior phase, contracting, colliding, or mirroring, that left delicate fingerprints in the cosmos we can, in principle, find. There are plausible, mathematically serious ways this could be, and the sky will play judge, slowly. Between these possibilities lies a deeper truth. The beginning, whatever it is not a violent clap demanding fear. It is a kindness. It grants us an arrow of time, a chance for complexity, an opportunity for matter to become memory. The low-entropy freshness of the early universe is the reason you remember yesterday, but not tomorrow. The reason stars could form. The reason warmth moves from hot tea to cool air. The reason we can tell stories that start and move forward. And we are part of that forward motion. Our curiosity is a continuation of the universe's first orderliness. When we build telescopes and detectors, when we tune them like instruments to the trembling of ancient light, we are extending that order, refining it. The cosmic microwave background soft, even, almost featureless still, holds tiny lilted notes that may tell us whether inflation danced, whether a bounce hushed the deepest waves, whether a prior eon left a ringed signature. We listen, and as we listen, we become more at home. If there is a wonder beyond the models, it is this. The question comes from a mind that the universe made, asking about the universe that made the mind. It is a loop, not of logical paradox, but of belonging. You sitting here are made of star ash and supernova gifts, arranged by gravity, sifted by time, propelled by chemical currents that remember. The fact that you can ask about before is a sign that time has done its work well, long enough and calmly enough to assemble cells that notice, neurons that compare, a heart that softens at a night sky. And if we never know for certain, if the best we can do is narrow the possibilities and glimpse signatures that lean one way, then we still haven't lost. We have gained a way to rest with the unknown, to let it be a wide ocean beyond the lantern's glow, to let it make us gentle. The universe is not a puzzle to beat. It is a place to be. Our questions do not have to end in answers to be valuable. They can end in better questions, kinder eyes, steadier breath. Step outside once more, if you can, or picture it if you can't. The stars are older than any nation, older than any story humans told around fires in caves. Yet you are the first version of the universe to see them exactly as you do right now. The Big Bang is not far. It hums in every photon, in the helium in your lungs, in the warmth your body gives off into the room. Whether there was a before or only a soft boundary where before loses meaning, you are inside it, held. Time has opened its hand, and you are one of the lines in its palm. Thank you for walking this path tonight, for letting science be a lullaby and mystery be a comfort. If you'd like to keep traveling with us into dark matter's quiet pull, into the music of exoplanets, into the winter of black holes and the spring of life, feel welcome to subscribe. No rush, no push. We'll be here, breathing with the tides of the cosmos, telling soft stories about the places we all come from. Sleep well, and let the universe keep singing.